just get started now. So yesterday we discussed about chapter 1, I mean chapter 2. We started discussing, and we basically, let me see. So what we did basically yesterday, we started discussing about how human brain neurons is compared with artificial neuron, and we basically discussed how we can implement this into some kind of mathematical function, turn them into mathematical functions, and also we understand how we can basically implement this is the way learning works. So you have your futures here, you have some weight and bias. Now you input them, then you have some threshold that determine what will be the output for binary 1 and 0. And now you compare your prediction with your class level, find the difference and the error, and now you update your weight based on the error. So this is what we discuss. This is what we call perceptron, right? This is called perceptron. And we will see the real learning later, but this is just for us to learn in the background, and we'll see the details in when we go. So this is how we show the perceptual learning algorithms. The first thing, we initialize, this is the x, this is the true value of the this is the target, this is the x, this is it, and now we define the algorithm, we initialize the weight, and now for every point future with its corresponding target, we iterate, we find the prediction of that one. So here y hat is the prediction, y I is the original, x is the future, and now we find the prediction, we multiply, this one, and we find the error, subtracting the original minus the prediction, and now we update the error, right? And now we go back. So this is a like kind of follow, which we, oh, okay, this is what we see the implementation of that today. Right. So let's look at it. So what we're gonna do today is basically to continue on the chapter 2, looking at how perceptron works, which gives us some kind of foundation on the future. So we'll see how perceptron is implemented in Python, NumPy and Python. We'll also see how perceptron is implemented in Pytorch. Right. So before that, let's just create a kind of toy data set. So this is a data set called Perceptron toy data.txt. If you look at the book, so let me look at Perceptron toy data. So this is the data set, you can see it. So here you have some point, and this is some features, and this is the class 0. When you have this and this is 0. So it's basically 0 and 1. When you have this and this is 0. So these are your xi. So this is x, x1, x2. So you can see this is the prediction. So this is the data set we want to train. We want to train based on this point, and now to predict whether it is 0 or whether it is 1. So that's what we're gonna do basically. Yeah. So if you look at the data set, we just read the data here, and now we basically divide the data into, here we do shuffling. You remember this is the class x the shape, which shows us class level count, np the bin count, how many we have. We have 50. Can you see that? And x the shape, how many do we have? We have the x is a training 100. So we have this is 100. You can see that is 100, right? We have 100, and the training we have how many? 1, 2 features, right? So you can see here we have 100 row and 2 columns, and the y, which is what we're gonna predict here, right? The prediction, this is it. So here we can see we have our y. Yeah, so here this is how we do it. This is the x and this is the y. This one, remember, this is the data. It means subset the data, because we read the data here and we say subset the data all rows. Remember, this is all rows, and this means that from 0 to 2 at column 2. So here we start from 0 at column 2, and it will stop at here. That will be assigned to variable x, and variable y will be assigned from all rows. Can you see that this is how we do subsection all rows, and start not this that is the last column 2. So here you can see what is the last column, 0, 1, 2. So column 2. This means that we want to do training, machine learning, in the sense that when we run this guy, let's look at what would be the X. If we can even go here and see our variables. So what is the value of X? We can see here. Yep. So you can see this is our X, right? This is our X, 0, 1. And what is our value Y? Y, we can see also Y here. Yes, so you can see this is Y, Y, right? So what we want to do is basically we want to train a model, Perceptron, that given this X, which is 2 data point, and given this Y, can we predict whether it is 1 or 0? Yeah, and here we just convert the Y to be of type int, yeah, and this is what we printed. And now we shuffle the data. So if you look at this guy, the first thing is, if we look at this, not this guy. Okay, let's look at this guy. So if we look at this variable, yeah, if we look at this data, we can see that this is this point and another point, it gives us 0, 0, 0, 0. But we can see that the data, it starts from 0, 0, 0, 0, 0, 0, 0. Can you see that? Then 1, 1, 1, right? So we need to shuffle the data so that maybe it will have 0, 1, 0, 1, something like that. Because if you train the model, we take from 1 to 70, it will be all the zeros. Because if you look at this, the zeros, they stopped, I think, at 50. Can you see that stop at 50? And now the remaining 50 are ones. So if we want to take our data sets X trend and Y trend, maybe we can take 1 to 70 to be training set. But you can see that if we take 1 to 70, all the data that includes 0 are in training set, and the test set will have only 1. So a good idea when you have your data first is to do shuffling, right? So how do you do shuffle? Here we create an index at np.arrange 0, y shape of 0. So what this means is this. Let me show you this. So here, what do we mean by shape? So remember we do Python. Who can tell us what this will return? Zaradin, what this guy will return if we call y.shape 0, what this will return?
It will return the size of, or it will return the size of the Y at 0.
Okay, yeah, so 100 ne kenan ko? So it means here we are creating an index like of this will return 100 here. Then we are creating, we are calling np.arrange. So what will this return now? So here, let's assume now we return. What will now this shuffle index will be, Zaradin? We are calling this guy arrange. What arrange does now?
np.arrange, it will now convert this to numpy array.
Okay, yeah, so let's look at it. So np.arrange, so you can see 0, 1, 2. It will create a numpy array of 100 shape, right? 100 size, 1, 2, 3, up to 199. Can you see that? So what we mean by this, so here we do that, but we want to take this 100 that we created, 0 to 100. We want to shuffle it, like in here to be 0, to here to be 99, here to be 7, here, shuffle it. So we call something np.random step. We use a random step to be 1, 2, 3, meaning shuffle the range. So we create a random generator here. So when we call this guy, let me show you. So when you call this guy, no, we call this. So you can see this is just a random state, meaning when we replicate, when we do some kind of random arrangement, the arrangement will still be the same when we run the same code. So look at this one here. Now I said, okay, I create this one. Now I say shuffle range the shuffle. I now to shuffle the index I created. So here, if I call this guy, let's look at what will happen. So look at it, shuffle the range that I created, but I call a function called shuffle. So shuffle is a function that will shuffle the index that we created previously. So let's look what will happen. So if I call this index. Yeah, can you see the index now? 96 is here, 27. Can you see it shuffled the data? Now the point is shuffle, meaning that now this, when we call this shuffle on our index, because remember here the index we created, which is 100, and now here we create this object random, and we do this. So this means that you can see here we already create our x, we create our y. This is our x if we already see it. So this is our x. Can you see that? This is our y. This, but we want to shuffle this. So how can we do that? So you can see here we call x shuffle index. Can you see that? X shuffle index and y shuffle index. So when we call this, when we run this, this x now will basically contain the shuffle index, and also y will contain the shuffle. So if we run this here, basically what we are trying to do is to create x trend, y test, x test, shuffle index. We create the first 70 for training, x trend, and x test the last 70. Can you see 70 to the end? Y trend also is index. Can you see 0 to 70? And the Y shuffle is 70. So basically here we are doing something manually. When we go to scikit-learn, you then need to remember this, like, but this is just a mere Python. We believe everyone here can do Python, but if you are confused, just let me know. But when we be starting using scikit-learn, you don't need to do all this stuff. You can just call a scikit-learn to do all this shuffling. We remember that. Now, this is how we create text. You remember in scikit-learn, you can just create a function,
Trend
just
test splits.
trend test. Yeah, trend test split to do that. But we are using this manually. But we also here shuffle the data. Now here, remember, we do normalization, right? So here we normalize the data. Normalize the data in the sense that some machine learning algorithm wants you to normalize the data. That is to have a mean of 0 and also the unit variance. So in this case, we normalize the data. You can see this is how we normalize. Here we create x, then we call a mean on the trend set, and also we call standard deviation. We find the mean, we find the standard deviation. Can you see that the mean is now assigned here? Mean standard deviation now of the trend data is assigned to sigma. Now, how can we normalize the data? So for you to do normalization, you said the original value x trend minus mean divided by standard deviation. This is how we do normalization. So you can see we do normalization on trend, and x test. So we do normalization only on this, guys, our futures, not the y, which is the target. So can you see that? So this is how we do normalization. But as I said, when we come to doing scikit-learn, we should know, we just call a function to do normalization. Or do you remember, Zaradin, do you remember a function, what we do in scikit-learn to do normalization?
Yes, like scalar.
Yes, exactly. Yeah. So we just call a scalar function to do normalization. So here is just, we are preferring our data. Here we do shuffling. Also in scikit-learn, we just call shuffle and stuff like that. So this is how we do. So you can see this our data set, and now this is it. So we yeah, remember, this is what I said, the standard deviation will be 1. So extend the STD, we call this, along this will always be 1 standard deviation in your data. And now we just create the data set. Now here we now here we plot the data, so we can see this is our data set. So class 0, we can see this is class 0, this is class 1. So we can see that this data is linearly separable. What do you mean by linearly separable? It means the data set can be separated, right? So you can see here, we can draw a line here like this to separate the, so therefore we do classification. And we should know that Perceptron, the idea of Perceptron divide data set based on 2 classes. So here, what we are doing is we are dividing our data set using Perceptron, and the Perceptron can be able to divide this data. Yep. So you can see this is our trend data, I believe, right? You can see X trend and Y trend for the test data. So we divide the data, remember, into training set and test set. So this is the data for test set. So we can see even for training, the algorithm will be able to classify it, and for the test set, the algorithm will be able to classify it. So this is just exploring how we create a random data set and trying to show how it looks like. Any question before we move on to implement the Perceptron algorithm? Any question? Right. Okay, so let's go on and implement the perceptron algorithm and see how it will work. Right, so if we want to do that, let me bring this guy here so that I can quickly reference it. This guy here, right? This guy. So what we do in perceptron algorithm, we define this, we initialize this. Let me go. So we will use basically somehow um, using class to define the perceptron. So here we call a class, we have a perceptron, a class called perceptron, and now we have a constructor. You remember each class may have init function, right? Init, remember all these things. If you you need to brush off your classes, I will share something, maybe you can do that. Now you can see our init function, it can receive number of features. So what I mean by number of features, how many features do we have? How many X do we have? So remember this guy. Yeah, so this is the number of features, X1, X2, X up to Xn. These are the number of features we have, right? So for example, let me bring this guy as well to make a reference. Which guy is that? Anyway, yeah. So what I mean by number of features is this. So we want to implement this perceptron. So this one X, we want to have it. So in for example, one in this example, let me see this the other thing. Yes. So this is the number. If we are working on this kind of data set, for example, sample data set or whatsoever, you can see this is feature 1, 2, 3, 4. So we have X1, X2 up to X4. These are the features. So this is what we define here, right? So number of features. Now, you remember now when you have the number of features, for you to assign the variable to a variable called num features, we need to basically use the self. Oh no, I don't want to use this one. I didn't explain? Oh God, okay. Don't bother about me with this one. No, this one. Okay. Yeah, I have another one that explain better. That explain so that we can yeah, so the same implementation with that one, but the other one there, I don't have an explanation. I don't know this one's here, but this is helpful to understand. There is no comment here, but it's still the same thing. So this is our perceptron we define, and what we're going to have is, you remember we have, if you have a class, you have parameters in your class and you have your attributes. So who can tell us what is parameter in a class, what is attribute in a class? When we define a class, we have parameters and attribute. Who can tell us? Falalu, can you help us with what is parameter in a class and attribute? Anyone? Okay, so here we have our class, we have parameters. So what we mean by parameters, for example, when we define a class, some input that will be defined when creating the object that will be given. So for example, when I have a perceptron, I want to create an object perceptron, I must, if I want to instantiate the object with some parameters, there I say x1, y, or z. So these are what I will use to instantiate this class object. These are called the parameters. But the object, the attribute, these are something that you create the object from the class. So let's look at the parameters we're gonna have. We have ETA, which is float, which is a learner rate between 0.1 and 1.0. So this is a learner rate. What this learner rate means is it defines how fast we try to reach convergence. We have number of iteration. Number of iteration is integer. That is how many passes we are going to do over the training data set. Remember yesterday we show how we do training, like the number of iteration you do 1, 2, 3, 4 up to n, up to the time the model reaches convergence, reaches a good number of accuracy. The random state. So here we will create a random number that we will initialize so that we can have the same for the same stuff when we run the algorithm. Then we have the attribute. So attribute the 1D array. So 1D is weight after fitting. So you remember, you can see here. Oh, this guy out. Let me bring it. So So we can see here, yeah, we can see here is a weight, right? So we want to have, how do we store this? Also, how do we store this X, that is the futures? So you can see here is 1D array. Weight is will be 1D array. That is just array containing the weight we are going to have, right? Also, if I go back here, it will be really helpful. Yes, this one. So you can see here where we have this weight. Can you see this weight, right? So we want to put them in an array, right? In just a single array, so we can put them. What about futures? Can we put the futures in an array as well? Can we put these futures in an array? We have like x1, x2 up to xn. So let's look at it. Yes, okay, yes, we can put them. So that is what we mean. So here you can see we have our weight, which will put them in an array. Then we have b, which is a scalar. So what is b? We remember b is this, right? This is a b, right? Which is basically a number which can be one. So b is not, we are not put b, it should, is just be a scalar, a single number. So in that case, we can define our b bias. Can you see that? A unit after, which is a scalar. What we mean by a scalar, just a number like one. So we initialize b bias to be one, just a scalar, right? And this will be like a weight vector. Yeah, so here we define what is called error list, which stores our error that we use in our when we do the stuff. Okay, so any question before we move on? So here we gonna see like we're gonna see to initiate. We have a function to initialize the class. To so any class we know it must have init constructor. So here you can see we have self, and the class must have a self. And now we define our learner rate. Remember here we said, okay, remember in class, what do you call here, what do we call this one in class? If we have this, it's called what? Who can tell us what is called this? Malama, what is what is called this one in Python?
It's docstring.
Yes, exactly. So docstring just help us to define, to let us when we share our code to other people, to see what the class is doing, what are the parameters that we define, what are the meanings. So it is always helpful to define your docstring whatsoever you're going to use. So you can see here now I said ETA, which we already defined. We say what is ETA? Somebody learning rate, which is the number between 0 and 0.1. And so here we define it. What is number of iteration? You can see that the number integer is passes. So now how many number are we going to do iteration? 50. And now random state we say is 1. So you can see these are so this is what I call parameters. So anything you see that as is under parameters is used to instantiate the class. Can you see that all these guys are here? But attribute, these are something that we have variable inside the class that we can have. So you can see here, and for you to instantiate these guys, we need to call sub.eta is equals to eta, sub.number of iteration is equals to sub.random state is equals to this. I believe we all remember with classes. It will be difficult if anybody here about having problem with classes, because if anyone is having an issue with classes, it will be difficult for him to understand this. But as I said previously, if you have any issue, you can. Yeah, can you hear me? Hello? Hello?
Yes, we can
Okay.
hear you.
Okay, so as I said, this is if somebody is not good with classes, he will find this somehow difficult. So, but don't bother. Even if you actually are not good in classes, I can arrange a session for other people with issue with classes, so that, because if you don't understand classes, it will be really difficult. But yeah, as I said, just let me know if you have issue with classes. So you can see here, we initialize our variable, which is this guy, the learner rate, the number of iteration and stuff like that, right? So this I initialize under the constructor init. Now we want to define a function called fit. So what do we do now? What we do is, given basically given your X1, your futures, giving you a weight, giving you a bias. What do? We pass them to this function, and now threshold, and now the threshold will decide whether it is 0 or 1 to make prediction, right? So we want to do this way. We want to do this prediction. We want to go through this way. So this is what we call fitting the data. So if you have a data, now fit the data is try to find the best weight that can minimize, that can do prediction. That is what we call fitting the data. So I have a data, now I want to fit. To fit the data means to find some weight that you can make prediction. So we create now a function called fit. So this idea, this is very, really helpful when we go to using scikit-learn. You can see we will just be calling a fit function to do some kind of forward, which is here, it's giving us the intuition how that fit comes from. Also, don't bother about this, all these, when you use the scikit-learn, we just call a function. We don't need to remember this, but this is just really giving us intuition. So this is a function called fit. Remember, for each function, it must have a self. It must start with self. That is why we put this self. Now we have our x and we have our y. So you can see here we have our x, right? This is our x and this is our y. So this y is the this is x1, x2, x up to xm. This y is also y1, y2, y up to ym, because whatsoever this is x1, one future, we have this. So let's look at it. So we want to fit the training data. Can you see? Fit training data. That is what we're going to do. So what are the parameters here? We have x, we have y. So the x is array like, which is basically number of examples and a number of features. Who can tell, who understand what this means? Why do we have this? The shape of the x should be this. Who can tell us this? And if you look at the shape of y, it's just n examples. So who can tell us why do we have this kind of shapes for different shape for x and y? Hmm? Okay, so if you look at this guy, we can see that the x, which is our training data, is array-like, but the shape. So here they are even telling you the shape should be n example and n feature. So what do you mean by this? So if we look at our x, can you see that? Our x is this, right? With number of features. So if we call this guy here, x, you can see x the shape. X train.
Wannan za ka ce da opening bracket din inda ba function ba ne.
What did I do?
Ka sa opening and closing brackets.
Yeah, sorry. So you can see here the shape. So you can see what I'm saying here is that n examples, how many number of examples do we have? And how many features do we have? So you can see the shape of x is number of example. We have 100 example, and you can see number of features. So you can see your x should always be of this shape. But what about y? So y, you remember y is a target, right? So when we call y, remember our y should be this guy. Yeah, you can see it's only 100, right? Because it's just a single stuff. So you can see this is the n example, number of example, which is the target, right? So this is something that let you know, oh, this is how this thing works. So right, and what it returns is return an object. So this is just stuff. So let's look at it now. What do we need to do first? We need to do this, multiply by this, right? Everyone, and add with this and do this. So let's look at this first. Now you can see here we have a random number. So here we create a random number here. We create a random number generator here to keep track of our work. Now we said, okay, save the W, random number generator. So here save the W here, we have a weight. So remember here we said, in fact, how do we get these weights? One way is just to initialize this weight to 0, but another way is just to initialize this weight from normal distribution or any distribution. For example, okay, now what is this? Look at this, normal. What is this normal? This is a normal distribution. If you want to create any number, you can see that it can be like a location. Okay, let me give you an example. Yep, something like this. Let's look at this. Yes, so let's look at this guy. So if you look at this guy, here you can see, okay, let me say this, not this guy. This should be 0, just this should be 0.1. So if you look at this, what this means is that normal, it has some kind of this, it has the scale, it has the size. So here we say 1000, this is the stuff. Now when we run this guy, you can see it generate numbers, right, within this standard normal distribution, right? We just create any number. So what I'm trying to say here is that we are creating a random numbers from normal distribution and assign them to our weight. We are not just using 0, 0, 0, but we are just drawing in random distribution numbers from. So this is what we use this to assign number to weight. Can you see that? Self.weight, because remember here we already have our weight. Where yeah, okay, we need to define a weight, right? So here you can see, we say, okay, this is a weight. And now here the bias. The bias, remember, what is bias? The bias is basically now we're going to oh, okay, right. Now you can see our weight is weight, the number of the weight should be, if we have 10 futures, then our weight should be 10. So here you can see the weight, 1D array, weight after. So here we created here and normal. But what is the size of this weight should be? The size of the weight should be the same size as our futures. Is that correct? The size of the weight, how many weight? If I have from x1 to 10 to x10, how many weight are we going to have? 1 to what?
1 to 10 as well.
1 to 10 as well. So in that case, now when we are creating the weight, can you see that I say, okay, create a random number from this is the scale. The size, how many do I need to do? I said, okay, size the shape that this guy. So if you look at this one, I say, okay, create this size the shape one here. You can see, let me see the size. You can see size, let me go back. Do I have two? Oh yeah, remember, yeah, remember my X, I have 2 classes, correct?
Yes.
Remember, do you remember that? I have 2 classes, right? Let me show you something here. Here. Okay. Yeah, so what I mean here is that my X, I have 2 classes. What are the classes? We have 0 and 1. I have 0 and 1. So what about if I said 0 here? Shift this one. Can you see it's 100, right? Because I have, so here, okay, let me just show us what is X so that we can better understand. Can we see the X is number of futures? We have 2, 1 and the second one. And how many do we have? We have 100 from this. Now, when I call this guy here, X the shape, and I said 0 here, this means this will give me the size of row. How many instances do I have? But when I have 1, it will give me how many X do I have? How many futures, the column do I have, right? I have only 2 futures. So here, what is telling us that we're gonna have weight 2, that is here. We're gonna have X1 and X2 and W1 and W2. So X1 is all the columns here we have is X1. So all these columns, this is X1, this is X2. This is X1, this is X2. Yes.
Dakta, na ɗauka tun farko kamar ka ce za a yi amfani da feature ɗaya ne ba features guda biyu ba.
Future guda ɗaya.
irin kamar feature guda ɗaya dan har graph ɗin da muka yi kamar ko feature biyu ka ce ne
Feature B
na
ne,
dukkan.
feature
Okay,
B ne ina ji.
okay.
Yes. Yeah. So yeah, so shine wannan muka creating with. And you remember, you remember here the bias is always, the bias is what? A single number, right? Bias is a single number. We say bias, it's a scalar. So you can see here we initialize our bias. So you can see here we have our weight and we have our bias. Yeah, I said that this, we are trying to get intuition on how, build the intuition on how the algorithm works. When we come later, you just don't need to do that. We can just call function, but here we are trying to build intuition. So here you can see we define our weight, we define our bias. Here np dot, here should be np dot float. So here our bias is just a single number, which is 0. So here our bias here, we just initialize it to be 0, something like that, which is a scalar. Oh, pop. Any question? So now we do that, and now we have a variable, an array called self.errors. So remember here, we just create an, remember here we have underscore here. So there is nothing, don't care about that. I know you, in Python, we know when we have this, sometime we use it to define here. And also if you read the book, he said why he did that. Yeah, you can see as a convention, we append an underscore to attribute that are not created often initialization of the object. But we do this by calling the object other method, for example, self.w. So we just append the, he just append this stuff. Now let's go now to do the training. So what do we mean now by? So we initialize our weight, we know our bias, and we have our x. So what remain now for you? We know our x, we know our weight, we know our bias. What remain for us? Abin da ya rage mana shine ai sai mu ta yin haka ko mu yi prediction, and now if we compare the error, then we go back and update the error. We do this, which is called epoch training. So this is called the epoch. So this is what we are going to implement now. We implement our x's, we implement our y, we implement our bias. Now what we are going to do is to pass through this, make prediction, compare the prediction with our class level, and now find the error and update the weight and bias. So this is what we are going to do. So you can see here, this is a 4. Can you see that 4? It means going iteration, right? For this, remember here, it's just because we don't need any variable, you can just say x or whatsoever, but we don't want the variable, so we just use underscore. This is also Python. In range of self.n iterator. So this is number of epoch. Here we can say epoch. So n iterator means number of iteration. How many iteration are we going to use? So you remember here we define n iterator 50. So meaning here we are going to use this 50 times 1, 2, 3, 4, 5, up to 50. So that's why here we have for in the range iterator. Here we say, okay, errors, the first error is 0, and we create an empty error. Now, remember here is that for us to do this, we take for each xi, we need to find what is the corresponding error and it is weight. For this one, we need to find what is the corresponding, how we can update it is weight, what is the corresponding error. So that also we need to go through for each xi. For each xi. So here as well, you can see for each xi and weight, we need to find the weight, because these weights are not the same weight. We are not going to assign the same weight. For example, this is 0.3, this is 0.2. No, the value of x will be different from your futures will have different weight. Maybe this weight is different as we saw yesterday. Remember yesterday we have different weight, right? If we go back to yesterday, let me quickly show us, remember us, the Google stuff we saw yesterday. Google Playground, whatsoever, what is it called? Playground, the TensorFlow stuff we saw yesterday.
Yes, it's playground.tensorflow.com, I think.
Yes. So you remember here, you can see this is weight 0.49. Can you see 0.1? Can you see 0. So this means that given this x, it must have its corresponding weight. So each one is having a different weight. So this means that we need to find for each weight. So here, that is why we say for each xi and it is target. So for each xi and it is target, meaning for each x1 and it is target. Remember, I told you what we have the target. It is prediction. It is original value for each xi. So what I mean by that is this. For each x, you can see this is one feature. This is the second feature. This is the our prediction. Our what do you call target, right? So for each xi, and it is target. For each x2, and it is target. Can you see that? That is how we're gonna do that. So this is give you for each x and target in zip. That is the x and it is corresponding target. How do you do that? What do we do? First, what we do is we calculate we do, okay, let me show that. What we do is we do this. What is this? Net. Okay, where is the mathematical stuff? Yeah, we calculate this one, right? First, we do calculate this x, these times weight, right? Which is the prediction. Here is the prediction, right? This one. No, again, this one. This is the prediction. So we say this times W, we apply this, we get this prediction. Now we find the error by this subtraction. Now this is what we're gonna do here. We say target, which is the true value minus what we do predict. So here, if you look at it here, target, can you see yi minus the prediction, which is this is a prediction. So it means we need to calculate the prediction first before we obtain our error. So you can see here, we have our target, which is true, minus prediction. So where is that prediction? This is the prediction function that do. So here you can see we just call prediction here. So this is the prediction. The prediction is np where self.net x, given x, if x is greater than 0.0, return 1, else return 0. Remember, this is how our prediction works, right? When we define our stuff. If we go back on how we do our prediction, just let's see this. Remember, here, this is it. So when we do this stuff, now if the prediction is greater than, is less than 0, equals 1, we say 0. But if it is greater than 0, then we say equals to 1. So this is what we are implementing here. So you can see this prediction. We call this net input. So what is net input? This is a net input again. So net input, what it's doing is that it takes the value and weight. Can you see that? np.x and weight. This dot is matrix multiplication plus bias. So this one, np x times w plus bias. This is this guy. This one, I need to bring this so that, yeah, I need to bring this one. And this is quite useful to understand the basic how this stuff is done, so that we can just, so this is it. Can you see that? X times weight plus bias, right? This is how we apply this. X times weight plus bias, that will give us the prediction y. So this is what we do here. Can you see that? Net input dot xw, meaning do this multiplication, because here you can see it is multiplication that separate them. X times w, then plus plus bias. So this is called the net input, right? So now if this is net input, we calculate this one, right? We calculate this one. Yes.
Ni har yanzu playground nake gani.
Okay. Heinz playground. Do you all see playground?
Yes.
Hello?
Yes.
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 Shine ni ina ji ana ta X da Y. Na dauka to ni am color blind dama. Na dauka ko kala ce ba na gani.
To ya kamata ku dinga irin taimaka min idan dai abin da ina ta.
Ni ina da matsalar kala dama, to na san ba ko ne
kala
zan gane ba.
Yanzu fa, what about now? Okay. Okay, sorry, please, I'm taking us, but I want us please to understand it, because it will really put the, yeah. So what I was saying is this. Remember, this is how we do the addition, right? We said X times weight plus bias, it will give us prediction, right? So this is what I'm doing now, what we are doing, net input. We define a function called net input, which finds that X, this is dot numpy, X and W will do this multiplication, matrix multiplication. This X times W and plus Y and plus B, our bias. So this next input, that is what is doing, this net input. And now for us to do the prediction, remember, is we call this function on top of the sum here. When we do summation here, we told, so what is the sum here? If it returns value less than 0, this function will say, okay, it is it will return 0 if it is less than 0. But if it is greater than 0, this function will say, okay, the classification is 1. So this is what we are doing now in this one, predict, because this is what helps us to predict this one. After we apply this stuff, it will predict. This is only doing summation. So this summation is defined within this function called net input, but the prediction here, the total here, this guy is now defined using this predict. So you can see this predict, we have our X. Now we use np.where, where we said self.net input. So net input, can you see that net input? When we call net input, given X, it will return this summation, because this is a function net input. So this summation now we determine, is it greater than 0.0? If it is greater than or equal to 0.0, then return 1. If it is not greater than or equal to 0, then return 0. So this is what we are implementing here, this guy. I don't know if that makes sense. Do we understand these two things, net input and predict?
It's making sense.
Okay. Okay.
Yeah.
If we understand this, then now let's go back to our for loop. So remember, in the for loop, this is what we are going to do. We are going to be doing this in this way, going loop by this, right? So we must calculate the net input, that is the summation of all these guys, and now apply the threshold function to give us an output, right, within the loop. So we define, so we have this now, we define this, and we already have this. So if you look at them here now, we already have this net input, which do the summation of X and W plus bias. And now here, determine if it is 1 or 0. We already have that. Now what we need to do is just to go inside the loop now and call this function. Now this is it. Now, how do we do the update? Now, so we want to find the update now. So remember here, we said, okay, for each X and target, we said, okay, target minus the prediction. So this is target minus prediction. Target minus prediction. Then will give us what? Error. Can you see the error? So what we are saying here is that we multiply by something, learning rate. So this is the change, target minus prediction, but we multiply by learning rate. Learning rate will speed up the stuff. So this is just a number, 0.1 or whatsoever we already defined. We can even remove it if you don't want to do learning rate, but we want. So we say learning rate times this. Now this is the update. But how do we update our weight? Remember, this is how we update our weight. We said the weight is equals to error times xi. That is xi at that particular point. What is your error, right? So here you can see, we said we can update our weight. Weight is equals to, remember this is plus, it means weight plus, right? Yeah, you all know this, right? Okay, let me just use this. This is weight, previous weight, right? Previous weight plus update. So what is the update? Can you see that this is the error we have, because this is the target minus this times xi. Can you see times xi? So this is how we calculate the error. Can you see that the weight, the update the weight? Weight is equals to new weight, because we say that if we do the prediction and we have an error, it means we need to change this weight. But how do we change the weight to update? We say the old one plus the error we got by subtracting this times the xi. That is that x, original x that we do the pass here, we get the error, so we multiply by it. So this is what we are implementing here. Can you see that? So we don't need to do this. We can put this as we already know. So this is how we update the weight. But how do you update the bias? The way we update the bias, we just do the update. We don't add any X to it. We just put the update here. So here, yeah, this is how we update the bias. And now we can see here we are just, the reason why here we didn't name this one to be error, to be update, is we are tackling, counting the number of errors we got during our iteration. So we append, remember here we create errors equals to 0. That is, we don't do any error. So here we are updating the error. That is, if the object is not equal to 0, if object is not equal to 0, that is that there is an error, then update our error. So we have 1 error, we have 2 error. So this is just counting the number of that we did a mistake is doing. So this is basically the implementation of what I'm doing here. Yeah. So this is really key to understand this. Anyone with question? So if you look at this, this means that we now be able to update our to create a class called Perceptron, and now we can use this to fit our data. Any question before we move on? Ask question, because this is really, so you can see this one for X is for each X, and for this 4 is for the number of epoch. So if you can see this one here, we have X1, X2, X3. So moving this one for this X is 1 epoch. So this means that now here I need to go for X1 to finish everything here and go back for X2. That is, after that means I've completed 1 epoch. So I'll go for another epoch, the outside for loop. So this is basically the implementation of that. Now, so let's look at how we can do training. Now you implement a Perceptron class. Let's see how we can do training. So how can we do training? Let's read in Iris dataset here. We do training. So this is Iris dataset. We load our dataset from Iris. Yeah, we already know this is Iris dataset. I have shown example here. We want to test our Perceptron implementation. As I said, we will restrict with 2 futures variables, we said. Yeah, so let's look at it. So here you can see we have this sepal YA. The first 50 is Setosa. The second 50 is Vesicula. The last 50 is Virginia. That is, we have 150. So we want to take only Setosa and Vesicula. That is the first 100, right? So you can see here, we want to select the first 100. Therefore, for Y, select the Setosa and Vesicula. iLock, you remember iLock, what it does is select numbers, right? So from 0 to 100, select the first 100, and the 4 columns are return the value. So you can see here, I have from 1 to 50 here to the end is 150, 100. So I'm selecting only 2 classes, Setosa and Vesicula. And now np.where is where I return the values right here. And now here np.where Y is equals to Iris or Setosa. Iris Setosa return 0 or 1. So I'm trying to change the class Setosa and Vesicula to be binary, not Setosa or Vesicula. So what this is saying is that wherever Y is equals to Iris Setosa, wherever is Setosa, return 0. Else, because you remember I subtract what first 100, it means the other class will automatically be what? Will be automatically be what? Will be automatically be Vesicula, right? Yes. So what I'm saying here is that I select the first 100. That is from here to here, first 100. I remember the class level is Setosa and Vesicula. So I say, okay, since I select the first 100, let's look at this one guy here. So if we do this, I select, you can see they are only Iris Setosa, Iris Vesicula. Can you see that these are the first 100? But I said, okay, why? But wherever is Iris Setosa, return it to be 0. Wherever is Vesicula, return it to be 1. So here I'm just changing it to be like 0 and 1, the classification to be 0 and 1.
Yes, understood.
Yeah, so extract the sepal length. Now here, remember this is our so you remember this is the data set we create now. We download the data, the data set here, which is DF. So remember here as well, we also have this guy, DF. This is the data, this 1 column, second, third, fourth. So now I say, okay, now this iLock, I still set the first 100, and select only sepal length and sepal petal length. Select only these two columns, first and second. So you remember here, you can see here, I select the first 100 and also select only the first two columns. Select the sepal length, and because you remember I have 4, right? 1, 2, 3, 4, which is this sepal length, sepal width, you know. So I select
We
the
are
two.
selecting the first and the third columns.
Exactly. Sorry, first and third. So this guy and this guy. Can you see that? So remember here we just say 0 and 2, right? So 0 means the first one, 2 means the third column, right? If you look at this one, this is the first sepal length and now petal length. So I'm selecting the sepal length and petal length. Thank you, Falalu. You are watching us. Yeah, you can see the petal length. So I select this. So here I just plot them. You can see that. So here you can see we have a data set, setosa and vesicular. So now we create a data set with 2 classes, setosa and vesicular, right? So all these guys, what we do here, we just basically try to create this data set, setosa and vesicular, which is basically Python stuff. So here we have our data set. We can see we classify this data set. So we want to call this perceptron algorithm that we created here to do classification for us. Now, how can we do classification with our perceptron algorithm? This is how we do it. So you remember perceptron, you just call the class perceptron, and now specify the number of the ETA, which is the learner rate, and specify the number of iteration you want to do. Maybe I want to do 20 iteration. Can you see that? Because you remember this is a perceptron we define, perceptron, and how many number of parameters does it have? It has like what do we call it? Learner rate, number of iteration, and random state. So this is what we have. So now, since we create our algorithm called perceptron, this is how you, when you are doing scikit-learn, you remember when you are doing scikit-learn, you just call an algorithm, whether random forest, whether decision tree. At the background, they were implemented like this. I don't know if if this is clicking to you. When you are doing you are doing scikit-learn, you just call the name of the algorithm to do some kind of fitting. So at the background, they were implemented in this approach. So here we are going to use the same thing. We just call our algorithm perceptron. We create an object called ppn, and now we provide the parameters, which is this and number of iteration. Now remember, we create a method that will fit in the data, which do the training. So which method is the fit here? Remember here we have a method called fit. Can you see the fit method? What this fit method does? If you remember, fit method is the one that do the training, right? And all this stuff, we are calling them inside our fit method. We call the predict. This predict, we call it here. But inside the predict, can you see predict call this function here? So fit is the one that is doing the training. So now when we call this guy fit here, we create an object here, and now we fit the data. Remember, when we were doing scikit-learn, we create and we associate an object, right? And we feed the data set. Do you remember this?
Yes.
Yes. So
Yes.
we now feed the data, and now since we feed the data, here we can plot the error. So now when we feed the data, now we train the model. Now here with this, we train the model. Fit the model means train the model. Train. What do you mean by when we call the fit? Remember what it's doing, calling the fit. When you call the fit, what it's doing is like it will create. You don't need to create this weight and bias. It automatically create them when we define the class. Now it will do for length of number. It will check for number of iteration we provided already. What is the target X1 and target? It will just do all this stuff. What we need to do is just to give our data set. So here you can see with this is we provide it, and now the fit method, what it takes is only the X, the training, and the target. Remember, this is the fit method. It will do everything for you. Fit method, it takes the training X and Y, the target, comma, and then it will do the calculation for you. So that is why we can say that class encapsulate many things you want to do in Python. So now when we want to do the stuff, we just call the class. We call the class, it instantiate, and now we call the fit method. Now the fit method will now do the training. It's now do the training. Now this is it. Now it now already, remember here also, when we create the fit, we create a variable called errors, which is empty. and now we initialized the 0 here. But when we are doing the training, this variable is now updated in the sense that how many errors you have, like you do when you train the model, how many errors do you have, you calculate the error. So we want to we want to float the error here. So here you can see plot range from 1 to the length of the errors. That is how many errors you have plus 1 and plus and here is the errors you have. So here you can see we just do the plotting, and here you can see you have your number of epoch, because here we say number of epoch, number of update. Also, we should know that here number of update that we have is still equals to the number of errors we have, because if we don't have error, we will not update. Yeah, if we don't have any error, then this will be 0. Target minus prediction, this will be 0. So you can see the update will not be the same. So here you can see we have the plotting here, we update it here, but let's look at how we can do. Oh, okay, this is basically I don't think I put where for train. Okay, yeah, so this we train the model here, train the model on the perceptron, and now here we show that at Epoch 66, our model, for example, at Epoch 1, look at the error it does. At Epoch 2, this at Epoch 3, the error goes to 3. Epoch 4, the error is 2. Epoch 5, the error is 1. At Epoch 6, the model starts to stabilize. That is, the error is reduced. You remember, we may not necessarily have the error to be 0. We are reducing the error to be minimal. So you can see here the model does a good performance by stopping at here. Our perceptron converge after the 6th epoch, and we should now be able to classify the training data. And here we just plot, this is just some plotting to show the how the model do the classification. It classified the data very well. Right, so this is basically the intuition about how the perceptron is implemented. The main idea we should take away is this. This is how algorithms are implemented, even if we come to scikit-learn using class API concept. And now what you need to do is just when you want to train the data, you are training your data set, a new data set. What you need to do is just call the algorithm. The algorithm we created now is called Perceptron. The algorithm we created is called Perceptron. You provide, you remember sometime we said that our algorithm has some kind of hyperparameter. So these are some of the hyperparameters like number of iteration. And now we call our data set, which is X and Y, and we train the model. So yeah, any question? Any question? Yeah, so there, Banseka, yeah, this is what I want to show. Evaluating the model. So when we do the training, let me take this one guy there. So you can see here, we do the training, we train the model, and we just show it. Let's evaluate the model. Evaluate the model. We remember that whenever we do train a model, we evaluate its performance, right? So evaluate the model. How can we do the evaluation on test set? So when we run this guy, okay, train. No, not this guy. On test set.
Amma kamar ba mu da wata method a cikin class ɗin da suna evaluate. Kamar ba mu da wata method a cikin shi class ɗinmu da suna evaluate.
Yes, exactly. Right. Yeah. So this is I want you in the previous one, I didn't include the method to do the evaluation, but we can take this method here. We can also have a method here. Oh, this is different implementation, Seth. It's different implementation. If you look at this one, I'll give you this one. So this is still the same. So this is the main idea. Let me introduce the main idea here. So for example, here, what is happening here is that, yeah. So what is happening here is that here we use different kind of, this is something different. It's not from the book that I try to follow, but this is I decided just to use the one in the book here. But the main idea is this. We do the training to evaluate is just call the forward and stuff like that. I will show us another example in the next slide, in the next example. Just don't bother about that. Now we know how to do the stuff. Let me show us. Any question before we move on? Any question? Let's see. Any question? Okay.
Idan kamar za mu kanikanci.
Yes,
a wannan is binary classification ne.
Yes.
So mun sa number of outputs din ya zama 2. Idan za mu kamar regression, tunda regression output, number of output then is 1. So kamar wani kanikanci za mu.
Yeah, so what we are doing here is basically Perceptron, which is basically classification. So this algorithm that we are working on is Perceptron that does classification of 2 things. This is like not that kind of algorithm that we'll see the algorithm that can do that, but this one. So here you can see I am using this like example of the book. It doesn't have the evaluate stuff in Agabe evaluation bar. They didn't do that, but let me see. They didn't evaluate, I think, right? Okay, yeah, they didn't evaluate. Okay, yeah, don't worry about that. I will show us in the next example. Okay, yeah, so to answer your question, this is, I think, Perceptron. And the basic idea of Perceptron, what it does is just classification. Yeah, not regression. Right. Any question?
Doctor, kamar inda farkon littafin ya mention regression din, ya faɗi algorithm din da yake ko?
Wallahi na mamanta. Okay, let's look at it. I don't know. Let's look at, can you point where exactly? Kuna ganin littafin ku yanzu?
Muna gani.
Okay. Anyway, yeah, I'm not sure if anyway, if we want to do regression, the main idea is just not to, all I know is like we use maybe the last layer that we do for classification, not to do classification 0 and 1, but to call something that will do like a classification at the last. I don't know what we should be using with this Perceptron. I don't know if Perceptron, I'm not sure actually whether Perceptron does the regression or not. I don't know, Falalu, if in the book they made mention whether Perceptron can be used for regression.
Yeah, yana regression. Tunda dama shi neural network dama unit ɗinsa na farko shine Perceptron ɗin nan. To in aka haɗa su da yawa kaga shine za a iya samun wani multi-layered Perceptron. Shine the basic dai idea na shi neural network ba shine dai Perceptron ba. Kuma neural network ana amfani da shi wajen classification da regression a da yadda nake tunani.
Yes. What I'm saying, yeah. So ina ga ko regression din ne ina ga what will happen is maybe wajen changing wajen classification, whether it is now, yeah, wajen wannan wajen something like this, wajen net input in them. So what I'm saying is, if we look at this, this is the basic idea. This is the basic idea of Perceptron. Whether if it's something is less than 0, we classify as 0. If it is greater than 1, it's classified as 1. This is the basic idea of Perceptron. So, but I don't know, like if it does regression. Yeah, but we can check that one.
Okay, thank you, sir.
Any question again? Okay, so let's move on. Using Perceptron, using Pytorch, kuma fa. Perceptron using Pytorch. Oh yeah, here there is evaluate. So let's go on with this one that is evaluate. So you can see now, oh, anyway, we haven't done Pytorch, right? But the code is still the same thing. So if you look at this, this is it. So this is a code for NumPy that we have just seen. This is the code for the Pytorch. We define the class Perceptron. And if you look at this one here and the other one we do, you can see here we instantiate something called device. So this is device is telling us that if you are running on GPU, use GPU. If you are running on CPU, use CPU, because we are going to use Pytorch. So here, the something here, you can see we initialize number of features, our class, and number of weight. Here you can see here we say number of features and subject weight. To define our weight, we said number of features, 1, and we define it, and the bias we say is 0. So if you look at our settings, this one, you can see here as well, when we do the initialization, we define our weight, we define our bias, which is 0 using NumPy. But also this one is still the same thing using Pytorch. We initialize zeros, the 1 and 0 that will do class.
Dakta ba ma ji fa.
Yawwa, shi na ɗauka ni ma ina ta so in magana, na ga na kasa ji na ko problem da kauji na da shi ba.
Kuma na ɗauka wani abu yake nemowa.
Amaji.
Hello, kuna ji na yanzu?
Muna ji yanzu.
Sorry da Allah. Sorry. What I was saying is that the previous implementation I showed, there is a variant one here that I tried to show, but I prefer I just show the one in the book. But since we understand the one I did explanation, let's go through this one. Is even more in line with what we'll be seeing when we go to deep learning. So this is it. Just bear with me. You can see we have forward. So here we can see we initialize a number of futures, which are this. Can you see that? We initialize our weight, which are this, and we initialize our bias. Can you see that? So you can see we initialize this. Now we're going to do this way, which is called forward. Now we define a function called forward. Given any futures, what are we going to do? We said, okay, weight times X, that is this weight times X plus bias, Can you see that? X times weight plus bias. Can you see that? And we define it to be float. And this threshold is the one that determines if the output is 1 or 0, right? So we call it here prediction. Can you see this is a prediction? NP that where the linear, that is the output of this multiplication, this one, the output of this one, this weight x1 times weight plus x2 times this plus bias. This, when you sum them, the output here, that is the linear, the output here, which is linear, the output when you sum them, right? The output, if it is greater than 0, then the prediction is what? 1. Can you see the prediction is 1, which is this? If it is less than 0, then the prediction is 0. So this is our prediction, return prediction. So this is forward pass. I wish this one is even more simpler to explain than the other one that I was working on. But this one is not in the book, but yeah, we should understand this one. It's more even more in line with when we go to using Pytorch neural network, because you will define forward, you will define backward. What is the meaning of forward? Going this way. I don't know if you understand how we get this one. Do we understand how we get this forward? And the forward, what it returns is prediction. That is prediction. Can you see from here to here? The last thing you return is prediction. That is this prediction. Now, what is backward? What do we do at backward? At backward, we take our prediction and now compare it with the original level and find the error, right? And now update this way. So let's look at the backward. Given the X and Y, what is X? What is Y? X is the original. Y is the target, original target. So given X and original target, prediction is, how do you get prediction? We're gonna get prediction, right? Prediction is self-forward. When I call this method call forward, self-forward given X will return this prediction. Can you see that? Will return this prediction. So we will have predictions. So predictions will be assigned to a value called prediction, because these are different methods. So we want to assess the result of this method inside this method, this function. Can you see that inside this method? So that's why we say self.forward, because remember in classes, you can assess method in another class. So this is a method called backward. I want to assess this method, so I need to use this self. So that's why I say self.forward. What this self.forward will return? The prediction. That is where this. Now, how do you find the error? The error is this, the prediction. Can you see that? This is prediction minus Y minus prediction, right? So this is it. Yeah, error. Can you see error is Y minus prediction? And now I return error. So you can see I have backward, I have forward, which is forward. This is forward, which this is backward. Now, what do I need to do now? It's just to do forward and backward in a loop. Forward and backward in a loop, forward and backward in a loop. So this is when we define. Then we define this training, because this forward and backward is a training, right? It's a training. So here we said, given X, given Y, given epoch, number of the training you want to do. Given like this, how many times do you want to do? So given this, so this we go through for each, for I in the range of shape of Y, that is the number of your target. And this is the number of epoch. This is the same as I explained before, given that. And now you do the training. So this training is like doing this equivalent to the number of epoch. And finally, this is evaluate. So what is the evaluate here? Self-forward. Okay, let me just go a little bit here inside this. So you can see this one, self, the backward and Y. Can you see that? Backward, self, I call the method called backward. What is the backward method? This is the backward. What do I have in the method? I have X and Y, right? So you can see here I have X, I, That is the first X and YI. So that means my first XI and YI. Can you see that? My first XI and YI. That is it. So that is the backward. And the backward, we can see what it does. Basically, it return the errors, right? So here we'll return the errors, which is this. Can we see that? And now we do the update. Weight, we update the weight. How do you update the weight? It's equals to errors times XI. Can we see that? And now bias is errors. We don't update bias. We just update the bias from previous bias plus errors. We don't multiply by XI. But why are we doing this stuff? You can see here we said, okay, reshape this XI, reshape it 1 to the sub number of futures. And here we can see we said YI. Remember here, this is YI. Why we do that? Because we can only do multiplication. I remember yesterday we talked about you can only do multiplication. So here I'm reshaping the X to be like row vector, because already Y is row vector. It's only one column. You remember target is right row. So here I'm reshaping this X to be in the same shape so that we can do this in backward. What do we do in backward? Remember we do when we in backward we call forward, and in forward we do dot product. That is X times Y. So that's why we do that. So this is basically how the Perceptron is implemented in this way. And so if we want to train the Perceptron, we just call our class Perceptron here. So we call the Perceptron. How many features do we have? You can see the Perceptron, the default number of features you're gonna have. We have it here. Number of features is 2. Now, when we do train, what do you call in training? You have your X, you have your Y training, and you have your number of epoch. How many epoch do you want to train? 5 epoch. So this is, I call the function train, X train, Y train, and the number of epoch is 5. Now, when I click this one, I now train a model. I train a model. Now, when I train this model, what do you know? We already know when we train a model, we said we learn weight and bias, right? We learn weight and bias. So here I model the parameter. I output the weight of the model. Can you see PPN? That is the object we created for the model times dot weight. Remember in object oriented. Now here I have a class, I create an object called PPN from the class Perceptron. Now, if I want to access any object, any variable, which is weight, for example, here, I have about, weight. I need to call this object PPN dot weight. This is something we should know. Also, if I want to access this bias, I need to call the object that I created PPN dot weight dot bias. So you can see these are the weight, these are the bias, because I have 2 input, right? 2 features, X1 and X2. So these are the weight and bias that we learn, that train the model to learn perfectly. I don't know if we understand this. So now, how can we evaluate the model? We have a method called here define evaluate. What evaluate does? Evaluate, what it does is it call we take our prediction and sum where the prediction is equal to the original Y. Sum, can you see sum? Where prediction is equal to the original Y, divide by total, divide by Y the shape. So this is evaluate and return the accuracy. So evaluate, return the accuracy. That is what it does. So we can see here, we can call train accuracy. If we use our X train, Y train, if we use the training data, when we run this guy, we can see we 100% the model learn to classify, do the classification 100% because we do it in the training set. Now, but when we use the test set, X test and Y test, we can see that the model now learn only 93%. The model learns only 93%, which is good. 93% is a good stuff. And now here we show the classification, how the model just classify the data. Yeah, so this is more even, I think, intuitive, and this is what we'll be using. So the main takeaway is like, we don't need to understand to say this is how, it's good to understand this, but when we start doing the scikit-learn, we just be doing these 2 lines to train a model. This one, all this one will be now implemented in scikit-learn. You don't need to know them. So this is how the scikit-learn works. You just call the algorithm, create a model, and do this. Any question? Okay, I think we are good. We are on top of the hour now. Daraddin, any question?
No, doctor.
Okay. Anyone with question? I think today I try to follow the book example, just because if you want to go through it, you will understand it. But I just give you a sense of using another approach, which looks more intuitive as well, that we should know. Sorry?
My question, sir.
Yes.
Apart from this what you have used as a plant, how can we apply this knowledge to solve another problems in our social life?
Yes. So this is a good question. So this Perceptron, we are not going to be using it in solving your problem, for example, in research. The way we will be solving our problem is from the next chapter 3 and 4. If we do chapter 3 and 4 in the book, we'll be able to train a machine learning model using scikit-learn, given a given data set. So we see that here we are just trying to build a foundation to see what is. If we go to the next chapter 3 and 4, you will see, oh, this is this scene. Okay. In no way now you want to train a model, you will use Perceptron, because this is very old method, a foundation for machine learning algorithm, or foundation of learning. So we are not going to use Perceptron to train a model, but we are building our intuition from the very basic. So if we go to chapter 2, let me see the book we are using. So if you look at it, then chapter 3 will talk about the tower of machine learning classifier. So using chapter 3 will give us a good intuition on solving a problem when we have our problem in our data set. If you have a data set you want to train, using finishing chapter 3 will give us a good intuition. Chapter 4, how you can build your data set, how you can do processing. Chapter 5, how you can do dimensionality reduction and stuff like that. But chapter 3, when we do chapter 3, then you are in good shape. If you have a data set, you can do modeling. In fact, after we finish chapter 3, we will not, I think, move to chapter 4. Maybe we will need to give a very problem that we're going to experiment, all of us, to see how we can train a machine learning model. Maybe we can use a Kaggle competition. Just give one Kaggle existing Kaggle to see how we can all solve it. Yes, Palalu, go on.
Doctor.
Yes.
About exercise.
Yanzu wai?
Ko ba yanzu ba, ko zuwa yanzu ma ko zuwa gobe. Sati mai zuwa kowa ya zo da shi.
Doctor, bari mu nuna.
Yeah. So one good thing shine a cikin wannan da akwai wani abin nan another so you can see here we use Perceptron, right? We use Perceptron, and this is but da akwai wani we may not go through it, but the next a littafin da sun yi wani abu bayanin wani abu shi kuma, which we may not have time now to go through it, but you can go through it and even try to solve it, which is this adaptive linear neurons and linear and convergence of learning. So this is another type of single linear neuron called adaptive linear neuron, which called Adeline. So how it works? Now, kun ga yanda muka yi amfani da Perceptron, don't bother about self. This is just giving us a test of foundation of how these things work. You will get a very understanding on how you can do when we go chapter 3. If you don't understand anything now, that is fine. We'll understand in this chapter. So this is basic. We understand Perceptron works. Given x1, x2, this are weight, we do summation and we do this. But there is another which is called adaptive linear neuron. Instead from summation, then summation. Remember here in Perceptron, within summation, we just apply our function that determine whether if the result of summation is greater than 0 is 1 or no. The result da shi na output ɗinmu, then ba za mu je mu threshold ɗin ba, da shi za mu za mu compare, za mu apply din one function here, activation function, sai mu find an error from our class level, we find an error, then we update the bias. I don't know, Coco got a difference between she adaptive linear neuron and perceptron. So this is how it works. In perceptron, when we do the summation no one multiplication y, then we apply the this threshold to classify. But she wanna adaptive linear neuron, we basically apply on the sum, we apply another activation function. We don't, you can see here, we don't actually make the prediction, but we do this. So this is something all historical. You can read it, and it is implementation also is here. We just alter a bit on how this is done. So Palalu, this is an assignment. Go and read how you can, the algorithm for this one works. Maybe in our next session, that can explain it in one. Yes, exactly. So please go on and read one. I just want to reiterate that this chapter 2 is just giving us an intuition on how these things works. It is in chapter 3 that you will see how we can just use a scikit-learn, just call a function. In 5 minutes, you train your machine learning model. In just 5 minutes, you train your machine learning model, you get your accuracy, you can do everything. Yeah. Any question? But what I also make sure that when we do go that train a machine learning model, like calling a classifiers, what is happening is that you should put in your mind that there is something that is implemented at the background. So this, like here, we implement a classifier algorithm called Perceptron, we implement it. Remember, you can see we do forward, we did backward, we do a saber. But when we train it, we just call Perceptron the class. And when we do train, we just call X train and now put the. So this is what we will be using when we are using scikit-learn. Only one line, the line would be only this one. All this one, we don't need to use them because at the back end, scikit-learn has already explained it. Yeah, some kind of abstraction. Okay. Any question? Hajia, akwai tambaya? Okay, any question?
No.
Okay. Right. Kuma, I thought we can do also implementation of this Perceptron in Pytorch, but I think it's not good since Bami Pytorch ba. Maybe in the subsequent sections, but this is the implementation in Pytorch, but we may not necessarily see it. Just now to understand what we discussed there. Yes, any question? No question. Noor, I remember ranar kin mun magana WhatsApp. How about your data set? Ban samu mun yi magana ba.
Wallahi, doctor, I was not able to do the web scraping. Shine kawai inda na matsani.
Oh, web scraping ne biki kika kasa? Na Wikipedia kenan?
Na Wikipedia, exactly.
Okay. How do you plan to do the create the summarization then?
Na ga wasu codes dai to su ya kamata a ce na yi amfani da su na samu na yi collecting articles din.
Hey.
But gaskiya I couldn't make it.
Okay. Right. So web scraping din ne yanzu abin. So abin da za ki magana, then we can see how we can do that. Yes.
Okay, thank you, doctor. Thank you so
Yes.
much.
Yes. Yeah, anyone with question? Okay. So please read chapter 3 before next week we go. I think chapter 3 yana da yawa. Maybe we can divide it into 2 sections, but I don't know if we can finish it in 1 section. But I read chapter 3 to get a sense of what is there. I did read it so that when we come, we'll like find it so easy to do a lot of other stuff. Okay. Are we good? Okay. So inshallah we see next week.
Thank you, sir.
Yes, salam.
Thank you, sir.